Okay, so welcome back. This is still part B of lecture 5, and we are going to talk about testing in this video. But before we do that, I want to quickly just finish up this discussion of the differences between local variables and instance variables. So local variables are variables inside a method. Instance variables, or data members, are defined outside methods. They are in classes. Unlike other languages, you cannot have global variables in Java. In Java, you have local variables, you have instance variables, which is inside the class. Okay, so local variables are inside a method, instance variables are outside methods but inside classes. Local variables only exist while the method executes. As soon as the method returns, they are gone. And we'll talk about later about where these local variables are stored in memory. This is a special place. Instance variables exist as long as the object exists. So when you create a new object, you're creating all of the instance memory for the instance variables as well. Local variables must be initialized before they are used, otherwise you get a compiler error. And instance variables are initialized in a constructor, or actually they are initialized by default to right when you say something like private double base price, something like this. This is automatically set to 0 for in Java. So all data members are set to 0, and then maybe they are changed in a constructor. Local variables can only be accessed from a method. You cannot access a local variable from outside the method. There are some ways to get around that, but let's just say for now that they can only be accessed from the method. Instance variables can be accessed from any class method. So getters, setters, those kinds of things are usually typical ways of accessing instance variables. Local variables are meaningful only during method execution. Instance variables are meaningful as long as the object is alive or it's still being used. Okay, so local variables can contain some intermediate values needed only during the execution method, and it's not part of the object state. Instance variables, as you guys have seen from the definitions of state and things like that, they represent an object's property, or it's part of the object state. Okay, so I hope these terms are clear. Local variables versus instance variables. If you want a quick example, these are local variables. They're inside the variable, inside the method. They're only accessible from, let's say, from here all the way down to the return statement. After that, there's no meaning to these variables. Data members are way up, usually put at the top of the class, although they don't have to be, but they are around as long as you create an object and that object is around, it's being used. These data members have meaning. Okay, so now let's move on to the main thing, which is testing. So testing a program, there's many ways to test it. You can take the entire program and run it. Sure, that's one way to run it. One way to test a program is by running it. But then if you have bugs, how do you check them out? Well, it turns out in large projects, when you have many hundreds of classes and hundreds of methods, running it is just not feasible. It takes way too much time. What's much more feasible and much more doable is actually to test every single method separately. Every single class, every single method. So that's what unit testing is all about. Test the class being implemented to make sure it behaves as expected. And then usually we test one method at a time, right? Or test for each method. Functional testing is test the entire system to ensure that it meets the customer's requirements or specifications. So sure, in the end, when unit testing is all done and every single class works, every single method works, then you want to test the entire program to make sure. What's really important is, of course, what the customer wants. So there is this way of writing programs called test-driven development or test-driven implementation. And the bottom line really is it's kind of hard to imagine sometimes, especially when you're just getting started with Java programming. When you say an implementation is test-driven, we write the test for a feature before we actually implement the feature itself. So that is, before we write a method, what the method does, we write the test. You might think, well, that doesn't make sense because you have to have something to test before you can test it. Well, turns out you just set up a shell of a method and then you sort of fake test it, and then you set up your test first, and then once you're satisfied with setting up the test, then you've put what you want to go into that method that you're testing. So incremental test-driven implementation is the most effective means of reducing time required to track down and correct bugs. Now, it may not seem that way when you have very small programs, but once you're out and working as a software developer on a big project, I've heard this many, many times from managers, from employers, that there's no other way. We have to use unit tests. You can't just run the entire program each time, find a bug, compile the whole thing. Even compiling a program might take maybe half an hour because they are so massive sometimes. So it's much more efficient to actually test each little piece. So test-driven aspects, some of the aspects of test-driven implementation are to code a little, test a little. Actually, maybe even flip this around, test a little and then code a little, test a little, code a little. Okay. So here's how we would set up what's called a stubbed implementation of the class that we're really interested in. So we're really interested in setting up a traffic signal program that uses a traffic signal class, which has green, yellow, and red as possibilities for the traffic signal light. And we have one int variable for the light. So this is actually our only real state. Only thing that constitutes the state of this traffic signal, of a traffic signal object. The rest are, as you can see, they're static data members, so they don't constitute the state according to the book. So remember that static variables are not instance variables. Light is an instance variable. These static variables are called class variables, and so and in this case they're just final, so they don't constitute the state. So now what we do is we set up this class, and it's sort of like a dummy class. It's just got an empty constructor, an empty get method for the light. This is supposed to return light. Suppose you could just return light here. That's okay because it's going to be 0 anyway, but typically what we do is we set up a stubbed implementation of all the methods. In this case, this getter method, this light method, just returns a default of 0. This command method doesn't do anything at all. You can do that. You can just leave it blank. If you have a void return type, you don't even need a return statement. For this query method, we do need to have a return type, and so we need to have a return statement. Okay, so now what we do is we set up a second class. So a traffic signal is what we're really interested in. We set up a second class called traffic signal test. Whatever class we're interested in, we add test to it. And you guys have seen this, I hope, when we set up the counter and counter test class. Same idea. So the traffic signal test is the client of the traffic signal class. So traffic signal test is the client, traffic signal is the server. So remember that terminology. Traffic signal test, the client creates one or more instances of the traffic signal server class and then uses the queries and commands of traffic signal. The user interface object might be separate and reports the test results to the user. What we will do is we will set up traffic signal test, the client of traffic signal, and then we'll set up a main class out here, which is going to be the client of the traffic signal test. So this is going to be the client of traffic signal, and it's going to be the server to some other class. That's the main class. Okay. So the traffic signal test class, all it needs is one thing, one data member, or one property, as we are referring to it now, or feature. Those are all words that mean the same thing. It's the traffic signal object that is going to be tested. So the function of the traffic signal test class is to test this traffic signal object that we create, that's the data member. So it specifies a single command for this class, that is run test. And that's usually what you do. You have one method where you run one or more tests. In this case, it's simple enough that we'll just run a single test to test the traffic signal object. How does the traffic signal test get a traffic signal to test? You have to create it. So you have to use the constructor. So a traffic signal could be an argument either to the traffic signal test constructor or to the method run test, but usually what you do is you have to create a data member traffic signal, and we'll take the second alternative, which is to have traffic signal be created by the traffic signal test using the constructor in the traffic signal test constructor. So here it is. In our traffic signal test class, we have a data member, which is of type traffic signal. The thing that we're really interested in, all of this is just testing. This our customer will never see. This is all for our own purposes to make sure that our $1 million traffic signal object is good to go. Okay, so we have a data member, the object to test. We have a constructor in which we create a new instance of traffic signal using the traffic signal constructor. So in one constructor we call the other constructor of the object that we're really interested in. And then finally we have the test. So right now it's empty, but this is what it should look like. You just have a public void, it's a command method, and then all it does is have a bunch of code that tests this signal object, which is a traffic signal object. Okay, so besides the traffic signal test class, you need some main class, that is a class with a main method, public static void main. All you do in that class is really just create a new instance of the traffic signal test. I guess we could have put this on one line, and then we call this run test method of this test object that we just created. That's it. That's all main has to do. Now you'll see this structure over and over again. I'm hoping some of you have remembered this from the counter test object where we were testing the counter object. Okay, how do we write tests? We use private methods testing each feature of traffic signal. We place these invocations of these methods in the run test. So we set up a whole bunch of methods in traffic signal, maybe one, maybe none, because the test might be so simple you can just put it all right into run test like we did with counter test. Or in this case we might want to set up a few private methods for each feature of the traffic signal. So for example, to test the initial state, we have a private method. So far we haven't really done a lot of private methods. Here is a situation where we might just want to make methods private, and then we call it from the run test method. All this does is print out some things and uses a query method to find the current state of the light data member in the traffic signal class. So right now if you run this test, we may get misleading or correct results because this traffic signal class has only been stubbed. That is, we only have a skeleton or outline basically of the traffic signal class. We really haven't put much code into it. So now let's take a look at the traffic signal class and see what kinds of methods should go in it. First of all, we should probably start with the constructor, and the constructor should just initialize all of its data members. There's only one really, light, and we initialize it to the green state. So the initial state of light should be green. So that's simple. So that's the traffic signal constructor. Next, if you look at the query method light, the test initial state, which we just saw, does invoke it right here. So we want to have the right value output, and in this case it's pretty simple. Just returns the value in the data member light, and we're done. Okay, so we look at the other methods next.